All right. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, everyone. I hope all of you are good today. We are going to continue our lesson for today. Before we start our lesson, let's pray. Amin. All right. As usual, please fill the attendance. I can give you also the link in the chat room. So that's the link for the attendance. All right. Well, you are filling the attendance. Let me share my screen. So we're going to continue our lesson today. I have to turn off my video. All right. So this is now lesson 21, I think. Yes, chemistry lesson 21, video conference, September 3rd, 2020. Okay, let's start then. Still, we're going to talk about the modern atomic theories. Lastly, we mentioned about the quantum numbers. So today we're going to continue with the electronic configuration. Yeah. After we know the quantum number, we're going to learn about the electronic configuration. But before that one, let's make a little bit of review about the quantum number. Okay, let's make a little bit review about that one. Okay, we're going to talk. I'm going to choose one student to talk. Okay, Damar Jati, can you turn on your microphone?
Yes, sir. Yes, sir.
Jati, do you remember how many quantum number we have?
4, if I'm not mistaken.
Okay, 4 quantum number. Can you tell me what are those 4 quantum number?
Wait a minute.
What's the first one?
Principal quantum number.
Yes, the first one is principal quantum number. Good. What is the second one?
Secondary quantum number.
It is secondary quantum number. And then?
Magnetic quantum number.
Good. Magnetic quantum number. Okay.
And spin
And last,
quantum number.
spin quantum number. Okay. Now for Rizky Sofyan, principal quantum number show you what?
About the size of
the size and energy level, isn't it?
yes.
What is the number for principal quantum number, and how can you use the notation? What notation you use for this?
N.
Small n, isn't it?
Yes.
What is the number?
1,
Can be 1, 2,
2, 3, 4.
and so on. Good. Okay, the second one, Sadewa. What do you think about secondary quantum number? It show you what?
Show the shape of the orbital.
Good. The shape of the orbital. Actually, secondary quantum number is the sub level, isn't it?
Yes.
Actually, it's a sub-level or subshell. We call that one. And it is show you the shape of the quantum number. How can we denote it with number?
Small l.
It is a small l. It can be, what will be the number? Starting from
0,
0, 1, 2, and
2,
3.
3.
Right? We have now 4 subshell. It is showing you that this is S, it is B, this is D, this is F, isn't it?
F.
Good.
Yes.
You know the shape, yeah? I show you the shape last lesson. Okay, let's continue. Dimas Raihan Gifari. What is
Check. Yes, sir.
quantum number?
Describe the orientation of an atomic orbit in space.
Okay, orientation of orbital, isn't it?
Yes, sir.
Okay. Okay, it is showing by
Small m with L small.
this like this. What will
Yes.
be the number?
0 until 3.
It is depends on the orbital, isn't it? If it is orbital S, it is only 0. If it is orbital P, it is from -1 to +1. But in general, we can say that from -L to +L. From -L to +L. So if L is 2, which is d orbital, so it's starting from -2 to +2. -2, -1, 0, +1, and +2. Good. Okay, the last one. Okay. We're going to talk for the last one. Let me find Ian Huga. What do you think, Ian Huga?
Yes, sir. I think the spin quantum number describe the direction in which the electron is spinning.
Okay, it is spin the electron, right? Spinning
Yeah.
the electron. Okay. It is showing by which notation?
Small m with S.
Yeah, small m with S. Sometimes in different book, they are using only S. Yeah, small m with substrate S or only S. It is also used in some of the book. Okay. What is the value for the spin quantum number? The possible value?
Positive 1/2 or negative 1/2.
Good. It will be positive 1/2 or it is negative 1/2. We have only 2 value of the spin quantum number. Good. These are the things that we learned last lesson. Okay. Now we are going to continue with the next one. Now we are going to learn about electron configuration. Okay. What is electron configuration? Okay, before we are talking about this, we are going to see first what is electron configuration. Electron configuration is like this. For example, if I have one, let's say that we have sodium atoms. Sodium atom, it is the symbol is Na, right? And it has 23 here. What is the name of the number in here? Do you remember?
Mass.
Atomic mass. And it is 11 in here. What does it mean is number?
Proton.
What is the name of this number?
Atomic number or atomic number or
Atomic
proton.
number, right? Atomic number or proton number, isn't it? Now I'm asking you,
Yeah.
what is the proton in these atoms? How many proton is it?
11.
11.
11 in like proton, good. What is the neutron?
M.
12.
12.
12. It is 23 minus 11, isn't it? It is 12. A neutron, very good. How about the electron?
Proton.
How many electron in here?
11.
Why this 11?
Same with proton.
Why it is the same with proton?
Because
Because the atom is neutral.
Yeah, this atom is neutral. This is not an ion, isn't it? There is no charge in here. If it is neutral, then we know that the number of proton will be equal to the number of electrons. So if proton is 11, electron also will be 11. But it will be different if we have sodium plus 1. Yeah, if we have sodium plus 1, then the proton and electron will be changing. Proton still the same 11. Here I have 11 proton, but the electron will be changing. If it is positive, then the electron will be how many electron? If I have positively charged
10.
sodium, it is 10 electron. Yeah, because it is positive, so 1 electron is gone. So why I'm showing you this? What is the important in here? The important is the electron, guys. So we're going to talk about this electron. So we are going to distribute this electron. We know that this is sodium atom. If it is neutral, there will be 11 electron. But this 11 electron, where is the place of this 11 electron? We know the concept of orbital, isn't it? Okay, we know the concept of orbital. What is orbital? It is
the bagian of
the
Place of
probability.
electron.
The probability to find the electron, right? Place probability to find the electron. So this 11 electron will be in the orbital. Isn't it like that? This 11 electron will be in the orbital, isn't it?
Yeah.
Do you agree with me? This 11 electron will be in the orbital, isn't it?
Yes.
Okay,
Yes.
but now the problem, this 11 electron in which orbital? We have many orbital, right? And there are also many electron here. So we are going to find out what is the place of this 11 electron. How to find this place of this 11 electron? We have to know the quantum number if we want to find the place of this 11 electron. And we know already the quantum number. Now, after we know the quantum number, we will put the electron in its orbital. In which orbital is the electrons? So this is what we are going to learn today. Okay, let me, sorry, how to erase all on, okay. Okay, now, after we know that one, now imagine that we have sodium atom and we have 11 electron, and we are going to put the electron in the orbital. And we have to find the orbital, which orbital is in the sodium atoms. To know that what configuration, we call this one as a configuration. Configuration is placing the electron, actually placing the electron in the orbitals. Placing the electron in the orbital, we call as the electron configuration. To know the electron configuration, there are some rule. Ada beberapa peraturan. There are some rule that you have to know. The first one is Pauli exclusion principle. The first one is Pauli exclusion principle. What Pauli exclusion principle says? Let's read here. There are no two electrons in an atom that can have the same 4 quantum number. No electrons in an atom that will have the same quantum number. It means that if I have 11 electron, okay, if I have 11 electron, all 11 electron will have 11 address. Is it clear? Is it clear, guys?
Yes, sir.
Ya. Jika ada 11 elektron, berarti ada 11 alamat. Isn't it? And this 11 address will not be the same for all of them. Okay? So for example, if I have an electron in n equal to 1, in L equal to 0, in ML is equal to 0, and in the S, for example, a plus half, another electron, I will have n equal to 1, L equal to 0, ML equal to 0 also, for example, and S must be different, must be minus half, because these two electrons, these two address cannot be the same. N can be the same, L can be the same, ML can be the same, but the S cannot be the same. What was the S? S, what is
Spin quantum number.
Spin quantum.
Spin quantum number, right? If it's plus half, it is clockwise, isn't it? And if it is minus half, it is counterclockwise. So if the three quantum number are different, then this S must be, if three quantum number are the same, then this S must be different. So that's why in an orbital, I'm going to, let's not use this one because it's difficult to draw later on. Let's use this slide. I'm going to show the orbital with this line, okay? If I have the orbital, if one of the electron is clockwise, remember, if it is clockwise, will be drawn by this arrow to up. The other electron must be
Counterclockwise.
counterclockwise, isn't it? So in an orbital, maximum, how many? In one orbital, maximum, how many electrons you have?
Two.
In one orbital, maximum, how many electrons? Look at this. How many electrons?
Two.
2 electrons. In one orbital, maximally, we have only 2 electrons, which is as half as minus half. Because if we have the third electron, then it will be S will be the same, or yes, S will be another half or another minus half. So it will be the same. So it's impossible to have more than 2 electrons. So in an orbital, maximum, we have only 2 electrons from here. Okay? Clear? Jadi orbital, apa itu pengertiannya? What is the orbital? The place where
Probability
you find the electron, isn't it? And in the orbital, how many electrons are maximum you have in one orbital?
2.
We have only 2 maximum or electron. One of them is clockwise, the other must be counterclockwise.
Counterclockwise.
It is impossible to have more than 2 electrons in an orbital. It's possible to have only one? Yes, if only 1 electron is possible, because I said this maximum number. Maximum is 2. It can be 1 also. Yeah, but it cannot be in one orbital 3 electron, because if 3 electron, then the S will be the same. Okay, 2 electrons must have the same S value, so it is impossible. Is it clear up to here?
Yes.
Do you have any question?
Yes,
No? Okay, good. Let's continue. The second one, the second rule, that was the first. So the second rule is, we call it the Albor rule or Albor process. The Albor principle basically states that the lowest energy orbital are filled first. Okay, the lowest energy orbital are filled first. Ini kata-kata kuncinya. The lowest energy orbital are filled first. Artinya apa ini? Which orbital will be
Terisi.
filled first? Orbital yang seperti apa?
Terkecil,
Hah?
energi terkecil akan terisi penuh terlebih dahulu.
Ya, berarti orbital yang paling rendah energinya akan diisi dahulu, isn't it?
Yes.
Yes. Now, that's why, because we are talking about the energy, then you have to know the energy level of each orbital. Bagaimana kalian taunya? How do you know the energy level of the orbital? You have to know the energy order, yeah, of energy order of orbital. Which one is lower? Which one is higher? Nah, for knowing this, there is no other way. You have to know this one by heart. You have to memorize this. Kalian harus menghafal ini. This is the order. Urutannya seperti ini. This is the order of filling the electron in the orbital. Artinya apa nih? What does it mean, this S? This S, what does it mean? This S?
Spin.
No.
Secondary quantum number.
Yes. This S showing you the subshell, isn't it? This S showing you the subshell. Okay. What is one refers to?
Principal quantum numbers.
Yes, this is principal quantum number or showing you the cell. Okay. So which one is the orbital then? Which one is the orbital? Orbital is inside the orbital, di mana adanya? Inside the, remember last lesson. Where is the orbital?
Inside subcell.
Yes, it is inside the subcell, guys. Don't forget. So the orbital is inside the subshell. Okay. So inside here, this is the subshell. Inside here, there will be orbital. Now, if I have S subshell, how many orbital I have? Last lesson sudah. Huh?
Zero.
Zero. S. Okay, we have to back again to
Zero.
last lesson. Okay. If you cannot make a connection, that's difficult, guys. If S L equal to 0, isn't it? If S L equal to 0, how many orbital in here? Only one. If P, how many orbital?
3.
3. P, 5. F, 7. Okay, do you remember this one? Yes. Okay, so let's make a connection again with this. So they have a connection, guys. So you have to follow every week. So here, if I have only S, there is only one orbital here. Let me show you by line. This is one orbital here. This also S, one orbital. But in this P, how many orbital? P.
3.
1, 2, 3. Okay, ada 3 di sini. This S 1 against this P 3. This S again 1. This D, how many orbital?
5.
1, 2, 3, 4, 5. Okay, you know all of this. But the point is you have to memorize this order. Nggak ada cara lain. Kamu harus menghafalkan ininya, urutannya. How to memorize this one is very easy. I'm going to show you the way to memorize this. The way is like this. What I'm doing is like this. S, P, S, P, S, D, P, S, D, P, and then after that one, S, F, D, P. Apa kalian melihat polanya? Can you see the pattern? S, SP, SP, SDP, SDP, SFDP. Can you see the pattern to memorize? Apakah kalian melihat pola untuk menghafalkannya? Ada polanya kan? S, SP, SP, SDP, SDP, SFDP. Ada polanya nggak? Ada kan? S, SP, SP ini satu pola nih. SDP, SDP pola yang lain, dan SFDP another pola. Isn't it?
Yes, sir.
Easy to memorize, isn't it? Is it easy or difficult?
Easy, sir.
Easy. S, SP,
Difficult.
SP, SDP, SDP, SFDP. This is the subshell. This is how to memorize subshell. Now I'm going to show you how to memorize the shell. It's very easy. For the shell, for S, cell S, for S always starting from number 1. Okay. For a shell S, subshell S is starting from number 1 shell. 1, 2, 3, 4, 5, 6. Okay, easy, yeah? 1, 2, 3, 4, 5, 6. You just give the number in S, starting from 1. How about P? P, you give the number starting from 2. 2. Because in shell number 1, there is no p orbital. P orbital will available in subshell number 2. So it is 2, 3, 4, 5, 5, S6. Oh, SFDP-nya ada 2 ya? SFDP, SFDP. Berarti ada tambah lagi. SFDP. Oke, ada 2 ya. So, SP, SP, SDP, SDP, SFDP, SFDP. Berarti S di sini berapa? S di sini? 7. 6 ya. 7. P di sini, obat P in here. 7. This is 6P, then this is 7P. So P will be starting from number 2. How about D? D starting from number 3.
3.
3, 4, 5, 6. And so F starting from number 4. Okay. 4 and 5. Now I have the order. Now you can check this order, the order that I made with the order in here will be the same. S, SP, SP, SDP, SDP, SFDP, SFDP. Isn't it? It's the same. Just the difference is the number in here. Now, what is the number in here showing you? This 2, 2, 6, 2, 6. What is showing you? It is showing you what?
The electron.
Yes, maximum number of electron. It is showing you the maximum number of electron. Now for S because there is only 1 orbital, so maximum number for 1 orbital will be 2 electrons. For P how many orbital? 3, isn't it? 1, 2, 3. Because because P have 3 orbital, so the maximum number of electron in P will be 6. D how many orbital? D have 5 orbital. 1, 2, 3, 4, 5. So the maximum number of electron will be 10. F how many orbital? F have 7 orbital. So how many maximum number of electron will be 14. Okay, is it clear? Di sini dulu, up to here. Is it clear? Do you have any question? Okay, clear? Can we move? Okay, let's move. Okay, the next one is Hund's rule. Sorry, this is the last one actually for electron configuration. Hund's rule. What is Hund's rule? Hund's rule say that the electrons are distributed among the orbital of a subshell of the same energy in a way that gives the maximum number of unpaired electrons. So how to distribute the electron among the orbital in the same energy in a way that give maximum number of, this one is important, unpaired electron, the maximum number of unpaired electron. This example will be easily understood by using the subshell that has more than one orbital. For example, if I have p subshell, how many orbital I have? How many orbital I have? P subshell? Huh? How many orbital? S, how many orbital? S. S only? One orbital. P? Three orbitals. So I will draw 3 lines because it's 3 orbital. D, how many orbital? D? 5. F, how many orbital? Or how many orbital?
7.
7. Okay. Good. Everybody understand this one. Now P have 3 orbital. Let's say that P has 3 orbital. How many maximum electron that P can have?
6.
Maximum is 6. Can we have only, for example, 4 electron?
Yes.
Yes, it's possible because maximum is 6. So I can have also 4 electron. Now, if I have 4 electron, where is the place of that 4 electron? Is it in here? Sorry. Remember that. Sorry. Okay. Sorry. Okay, for example, if I have P 1, 2, 3, now I have 4 electrons, for example. You can draw like this. Can you draw like this? 4 electron? Can you draw like this? Huh? It is?
No, sir.
P. Why cannot be? This one, what you see here?
Spin.
Yes.
Spin a clock.
Okay. Pauli principles say that it is impossible to have 2 electrons in the same orbital with the same s. So it is wrong. Totally wrong here. This is also wrong. Okay. So it must be, if I have 3 orbital, so the possible is like this: 1 up, 1 down, 1 up, 1 down. Now, if I'm drawing like this, is it possible?
Yes, sir.
Yes, sir.
According to the Pauli, it is possible. But remember, we have also Hund's rule. Hund's rule said that if we want to distribute the electron among the orbital in the same energy, these orbitals are in the same energy, you are going to distribute the electron that give the maximum number of unpaired electron. What does it mean, maximum number of unpaired electron? Artinya kita harus membuat elektron tidak berpasangan, unpaired, secara maksimum. Now I have still 1 orbital here, so it is not maximum. So what should you do? You should make first the electron unpaired. So this is also wrong. This one is wrong. According to the Hund's, is wrong. According to Pauli, this is true, but according to Hund, this is wrong. Why it is wrong? According to Hund, if I have 4 electrons, I have to distribute electron like this. First, I'm going to give it up to the first orbital, and before I'm giving down to in the first orbital, I have to give up first to the second orbital. Oke, nggak bisa langsung kedua. Why? Because I have to make maximum number of unpaired. Saya harus membuat dia maksimum dulu, tidak berpasangan. Baru after that, then you can make it paired. So if I have 4 here, one first like this, the second like this, the third must be like this. Now it is maximum already unpaired. Okay? After I do this one, then if still I have 4 electron, then I will make it down. Then it is true. I will pair it. So before you make the maximum unpaired, you cannot make it paired. Sebelum kalian membuat dia maksimum dulu tidak berpasangan, kalian tidak bisa memasangkannya. You cannot make the electron paired before you make it maximum unpaired. Okay? So if I have, let's say that P5, then how to do that one? Satu sini, the second one here, the third one here. Now maksimum sudah unpaired maksimum ya. And then the fourth one here, the fifth one here. Okay, is it clear? Do you have any question? Do you have any question, guys?
I think no, sir.
Everything is clear, right?
Yes, sir.
Okay, so
Yes, sir.
this is what I'm going to explain to you today. So we have 3 rules to make an electron configuration. The first one is Pauli exclusion rule. Pauli exclusion is showing you that in one orbital maximum can only have 2 electrons, and 1 electron, if it is up clockwise, the second electron will be counterclockwise. They cannot be in the same direction. Okay, this is what Pauli exclusion principle say. And then the second one, outbound process or outbound energy order. In here, you have to memorize this order. I explained you to how to memorize that one. You have to know the order as SP, SP, SDP, SDP, SFDP, SFDP, and you have to know to give the number to the principal quantum number to this subshell. And then after that, Hunsul said that if you have the orbital in the same energy, then you have to distribute the electron. First, you have to make maximum unpaired electron, and after that, you going to pair the electron. So these 3 rules are important to knowing how to make the electronic configuration. Okay, next lesson, we are going to learn how to make the electronic configuration. Ini baru rule-nya saja. This is just only the rule ya. And next lesson, we are going to see how to make the electronic configuration. Bagaimana membuat konfigurasinya, pelajaran selanjutnya. That's enough for today. Don't forget, we will have some post-test again, 2 questions in the 15:25 after you finish the last lesson. I think that's enough if you don't have any question. Do you have a question? No? Thank you. See you next lesson. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, sir.